we have studied an interesting example of reactive intermediate Carbanion. First step is the introduction, just definition of Carbanion. Yes, it is trivalent, negatively charged carbon species having 8 electrons in its valence shell. Also about the properties of Carbanion. Then second point is the structure of Carbanion. Third point is the generation of Carbanion, how it is generated. Then fourth point is the stability of Carbanion. And last fifth point is the reactivity of Carbanion. Last point, reactivity of Carbanion. We will see some of the examples of chemical reaction. यामध्ये आपण काही chemical reaction चे example बघणार आहोत. And those reactions which involve formation of Carbanion as an intermediate. There are so many organic reactions which involve formation of Carbanion as an intermediate. Also, there is one topic belongs to that one, organic synthesis via enolate. There is a formation of Carbanion enolate ion from the active methylene compound due to abstraction of hydrogen by base. Okay, this topic also belongs to the same reactivity of Carbanion. Let us see first example, very simple example. What is meant by aldol condensation? Okay, suppose this is aldehyde CS3CHO. When this aldehyde, yes, it is an example of aldehyde. The name of particular compound is acetaldehyde. When it is treated with base, suppose it is warm with dilute alkali, dilute NaOH, then it undergoes self-condensation. Means 2 molecules of acetaldehyde, suppose, participate in the reaction. And here 1 molecule of aldehyde adds across the C double bond O group of another. 1 alpha hydrogen atom adds to oxygen, and remaining part of the aldehyde, it adds to the carbonyl carbon, and we get the corresponding beta hydroxyaldehyde. Yes, this is example of beta hydroxyaldehyde. Name of the particular compound is beta hydroxybutyraldehyde. Why it is butyraldehyde? Because this is a long chain compound. It having total 4 carbon atoms in the chain. Therefore, it is butyraldehyde. While beta carbon having OH group, hence it is beta hydroxybutyraldehyde, and that compound is also called as the aldol. Aldol, in aldol, ALD for aldehyde and OL for alcohol. Means that compound having 2 functional groups. One is aldehyde and second is alcohol. When aldehyde, which having alpha hydrogen atom, will warm with dilute alkali, undergo self-condensation, and we get the beta hydroxyaldehyde. That reaction is called aldol. Now, that reaction is also shown by ketone also. Initially, that reaction was studied only for aldehyde, and hence name is aldol. But later on, it was discovered that that reaction is also shown by ketone also, which having alpha hydrogen atom. Now let us see mechanism of this reaction. Mechanism means detailed discussion of reaction, how actually that reaction takes place. Okay, let us see first step for the aldol condensation. Okay, this is our aldehyde molecule, this is our acetaldehyde molecule. In the first step, what happens? We are using alkali, we are using base, and that base can be abstract alpha hydrogen atom from the aldehyde. Suppose this is OH minus ion from the base. It takes that alpha hydrogen atom, means that OH minus and hydrogen, it form water molecule. And during that process, the bond between carbon and hydrogen undergo breaking, and this electron pair goes on the carbon, and as carbon now acquires negative charge, and this is nothing but the carbanion, and that H and OH form water molecule. Thus, in first step, this takes 1 hydrogen, 1 alpha hydrogen from the acetaldehyde to form carbanion. This is the first step. In second step, that carbanion attack on the another molecule of aldehyde. It attack on the another molecule of aldehyde, means here there is a negative charge on the carbon, and this negative charge means electron pair. It form a bond with that carbonyl carbon. It act as a nucleophile. Carbanion act as a nucleophile, and it attack on the carbonyl carbon of another molecule of acetaldehyde. There is a formation of bond between these 2 carbon. Therefore, to maintain the valency, this pi bond undergo breaking, and electron pair goes on the oxygen. It acquires negative charge, and we get the intermediate alkoxide ion. Okay, this is the intermediate alkoxide ion. Actually, this is the new bond. This is the new bond. While here there is a single bond and oxygen having negative charge, we are having alkoxide intermediate. Now this alkoxide intermediate further takes 1 hydrogen, 1 proton from the water molecule, and it converts into corresponding beta hydroxyaldehyde, and that is we get aldol as a final product. Okay, this is just example of organic reaction. This is mechanism of aldol condensation. And in this reaction, we have studied how there is a formation of carbanion as an intermediate. What is the role of carbanion? What is the reactivity of carbanion? Let us see one more very important example regarding the same intermediate, Novengel condensation. This is very important reaction actually, Novengel condensation. And this reaction is shown by active methylene compound. When active methylene compounds are created with the aldehyde, for example, suppose benzaldehyde. Okay, I have taken example of benzaldehyde. When it reacted with active methylene compound, let us see same CH2COO C2H5O. Okay, this is diethyl malonate. Example of active methylene compound. This is methylene group attached by both sides by electron withdrawing group. Hence, it is active methylene compound. When this benzaldehyde is created with active methylene compound, that reaction is carried out in presence of base. Base, suppose example of base is R3N, means it is trialkyl amine. Then what happens? The two molecules undergo condensation. We can simply say that oxygen and that two hydrogen form H2O, then double bond appears in between that two carbon, and there is the formation of such double bonded compound, and this is nothing but the alpha beta unsaturated intermediate. This is the Novengel condensation. Now let us see mechanism of this reaction. Okay, this is diethyl, actually not methyl, this is diethyl malonate. In first step, it reacts with the base. We know that base having ability to abstract hydrogen atom from the active methylene compound. It takes that hydrogen atom from the active methylene compound. While this bond undergo breaking, electron pair goes towards carbon. Carbon acquires negative charge. Okay, this is R3NH, and the carbon acquires negative charge, and there is a formation of carbanion. Okay, this is very common step. Any active methylene compound on reaction with base easily loses hydrogen. Base abstract that hydrogen, and there is a formation of carbanion. Now, in the second step, that carbanion further attack on the aldehyde molecule. We have taken example of benzaldehyde. Suppose this is C6H5O, C double bond OH. Yes, it is benzaldehyde. This carbanion act as a nucleophile and it attack on the carbonyl carbon. Why? To maintain the valency of this carbon, this pi bond undergo breaking and this electron pair goes on the oxygen and it acquires negative charge. Okay, this is the new bond between the two carbon. Why? There is a single bond and this oxygen having negative charge. Okay, what should be the next step? Okay, now this alkoxide ion takes one proton and we get the corresponding hydroxy compound. Now this hydroxy compound further loses water molecule. त्यामधून H2O बाहेर पडतो, OH from this carbon, hydrogen from the adjacent carbon, water molecule बाहेर पडेल, double bond appears in between these two carbon, and there is a formation of alpha beta unsaturated product. Okay, this is alpha beta unsaturated product. Reaction is called Novengel condensation, and this reaction is also involved formation of carbanion as an intermediate. Reaction between aromatic aldehyde and active methylene compound. In presence of base, there is a formation of alpha beta unsaturated compound. Let us see another example of elimination reaction. Okay, this is beta phenyl ethyl bromide. Beta phenyl ethyl bromide on a reaction with base, it can easily lose that hydrogen. Okay, in presence of base, it can easily lose that hydrogen. Okay, it's like hydrogen को easily lose करू शकतो. That electron pair goes on the carbon and carbon acquires negative charge. त्यावरती negative charge येतो. We get the carbanion. Okay, this is the carbanion. Now this carbanion, this electron pair form a pi bond between these two. It's a pi bond pair. Therefore, this bond undergo breaking. Electron pair goes on the bromine. There is a loss of Br minus. तिथून Br minus बाहेर पडेल. या दोन्हीच्यामध्ये double bond येतो, and there is a formation of interesting compound. And this is nothing but the styrene. Name of the compound is a styrene. Actually, this styrene is the basic molecule, or it is the starting material used for the preparation of some polymer like polystyrene. That polystyrenes can be synthesized by using that styrene, and that styrene is prepared by using beta phenyl ethyl bromide, and during that reaction there is a formation of carbanion as an intermediate. Okay, this is actually example of elimination reaction, because there is a elimination of one hydrogen atom and one bromine from the molecule, and double bond appears in between that two carbon, and there is a formation of styrene. This is example of elimination reaction. But during that elimination, there is a formation of carbanion as an intermediate. Okay, now let us see example of rearrangement reaction. Okay, here, now this molecule in presence of base, in presence of PHLI means phenyllithium, example of strong base, it is example of strong base. Now, in presence of that phenyllithium, what happens? It can easily lose that hydrogen. इथून एक हायड्रोजन बाहेर पडतो. म्हणजे बेसची टेंडन्सी काय आहे? बेस टेक्स that hydrogen atom. Means this bond undergo breaking, electron pair goes towards carbon, and there is formation of carbanion. Just या ठिकाणचा एक हायड्रोजन ॲटम जो आहे तो हा phenyllithium strong base आहे, very strong base actually. There is a formation of carbanion. Now this carbanion further undergo rearrangement. यामध्ये rearrangement कशी होते बघा, या ठिकाणचा हा जो मिथिल ग्रुप आहे, मिथिल ग्रुप goes towards that carbon, negatively charged carbon, and there is a formation of corresponding product. म्हणजे सिंपली आपण असं म्हणूया, इथला बॉन्ड ब्रेक होतोय, इलेक्ट्रॉन पेअर नायट्रोजन कडे जाईल, इट बिकम्स न्यूट्रल, आणि हा जो मिथिल कार्बोकॅटायन आहे तो या ठिकाणी इकडे शिफ्ट होतोय towards that carbon which having negative charge towards carbanion, and this is rearrangement. Rearrangement, why it is rearrangement? Because there is a migration of methyl group takes place from nitrogen to carbon. Therefore, it is example of rearrangement reaction. Okay, this is just about the reactivity of carbanion. We have studied an interesting example of reactive intermediate, carbanion. Studied that carbanion in 5 steps. First step is the introduction. Then second point is the structure of carbanion. Third point is the generation of carbanion, how it is generated. Then fourth point is the stability of carbanion. And last fifth point is the reactivity of carbanion. And under that heading, we have studied some of the examples of organic reaction. And that organic reaction involves formation of carbanion as an intermediate. Okay, this is about the second reaction, intermediate carbanion.